How do you build your COBOL applications in the mainframe? Are you still using a traditional source code repository such as Changeman, Endeavor, or even the IBM SCLM? Is it centralized? Does it allow for true parallel development? In this demo, I, Anderson Pedraza from IBM Deutschland, IBM Germany, I will demonstrate how we can use dependency-based build to compile and link edit a COBOL program using Git, using a modern source code repository or version control system that allows for true parallel development and that will help modernize the way your developers work with COBOL applications. So this is an environment I got created for me, and this is part of the Z trial offering. So you are able to request an environment like this. It will last for 3 days, and you can run this demo for yourself or your team or with your team of developers. So for this demo, we will start with this first scenario. It will take for you to run approximately 30 minutes. And we will consider that the source code is already at the Git repository. So the first step will be to clone the source code to my local environment. So we'll start the scenario. And here we can see that the first thing is that we are going to bring to this x86, so this Windows machine I'm using, we are going to clone the source code that is here in GitHub. In this environment, in this x86, this x86 machine is a virtual desktop, a virtual Windows system running in the cloud. So this Z trial created for me this Windows server. So I can see here system and see it's a Windows Server 2012, and this is in the cloud. So I have access to both Windows machine and also access to a virtual ZOS, LPAR. And the ZOS is also running in a virtual environment, a virtual x86. So it's not a real ZOS LPAR, not a real ZOS logical partition, but it's an emulated ZOS running on x86. So for the purpose of this Z trial, in the cloud we have two virtual machines, this x86 running Windows and another x86 virtual machine running Linux and emulating ZOS LPAR. Our first step is then to clone or to copy the source code files from this GitHub to this x86 Windows machine. And we will use to do this the IBM OpenZ development. And you will see it's very similar. So for those that are familiar with IDZ, IBM Developer for Z, you will see it's a very similar product. Doesn't have all the functions of the full IDZ, but you will see it's a very similar environment, also based on Eclipse. And this is also an important aspect of modernization, to have the developers that are writing COBOL, assembler, PL1 code to interact with a modern IDE. So let's go for it. We will clone the Git repository. So we have here already the Z Open Development, the IDE. And the first thing we are going to do is to change the perspective. So Eclipse works with different perspectives. So a perspective is the collection of views. And we are going to open the Git perspectives. And this is the perspective that will allow us to work with the Git repositories. So let's start with this clone a Git repository. I have here already the SSH, also the URI, the unique resource identifier for where the source code is. So this is git at zos.dev. So git at this server I have in my Z trial. And I'm going to clone a hospital application. So this is the demo application we are going to use. So at this point, we are using a Git plugin, and I have already marked that I want to clone the master branch. So if I had more than one branch at the Git repository, I could select what branch I wanted to clone. And I'm going to save this to my C drive, to my Windows, for my user. So I have this role of administrator. So this is where the cloning is being done. So I have now in the Git repositories view an entry for the hospital application, and in working tree I can see the COBOL source code, and I can also move to the ZOS projects. So this is another perspective. This is the open development perspective, and I see here already my COBOL source code. With a double click, I can open the COBOL program, and I could start working here. Since this is a hospital application, and we see here that this program deals with daily treatment data, but maybe the developer would like to understand better the source code. So we have here the COBOL file, but in order to understand better how this program is organized, the developer could use here outline view of the environment division or the procedure division and the paragraphs, but also with a right click, select show in the program control flow. So this will generate here the control flow of this program, and we can maximize this to have a better understanding of how the program is organized, and for instance to see where we do the reading of the treatment data. So we see here a read statement. We could check this right treatment error. So we can use this to understand the go-tos and performs of the source code, and this way the developer would have a better understanding. So at this point we can reset the perspective, so we can every time we change the views or change the position of the views, or maybe we want to resize, we can go back to window perspective and reset perspective, and this way we can get back to the layout that we are used to work with. If we want to persist or to save the perspective, we can create a new one with our preferences, the sizing and the position of the views inside the layout. So now we are ready to move forward and run an initial user build of our COBOL application. So one important aspect of the user build is that this build will be isolated. We are not going to compete nor influence or disrupt the work that our other that other developers are doing. So we are not going to impact the other team members. And with this initial build, we are going to produce the executables of this hospital application. So right now we are going to connect to the ZOS system. We see here it is called ZOS.dev, and we can access from here the high-level qualifier DBB, for instance. So I'm going to enter the password. And see the connection going on. And now I can see that this high-level qualifier is at this point empty. So I do see under IBM user other datasets, but with the high-level qualifier DBB, we don't have any other datasets or libraries that starts with this HLQ. So the ZOS, we are connected here using the remote systems view. We can connect directly using Pcon, and I will do logon TSO and enter the IBM user, followed by the password. And we can see here with the option 3.4 that for DBB, or starting with this high-level qualifier, we don't have libraries or datasets. But if I start with IBM user, I can see the datasets and other libraries and objects that are being shown here in this view. So before doing the build, before running the build, I want to add some modification to this program, and by the execution I will be sure that I'm executing the treatment program, the patient treatment program that we are looking to. So I'm going to use here and this outline view, and with the procedure division I see the paragraph 000 that does housekeeping. But I want to use this display command, and I will insert display. So before this perform display DBB demo before housekeeping, a final point, and I want to write another display DBB demo after cleanup. So these are the modifications we inserted to our program. We see here now an asterisk that indicates that this program has been changed, and I can ask to file save or use Ctrl S to save this. And now I see this symbol greater than, indicating that this is one source code that was changed after after I cloned the Git repository. So to start the build of this particular program, I will right click on it in this ZOS project view, go to dependency based build, and request DBB user build. So first I get this wizard, and the first thing I need to select is what ZOS system I will use. Could be a real ZOS LPAR, or in this case using a ZDNT, a Z developer and test virtualized emulated ZOS. So I'm going to build against or in this ZOS virtual LPAR. Next, I need to select what build script I'm going to use. So I'm going to browse, and the build scripts can be part of the repository. So how to build the software could evolve and go along and be as dynamic as the source code, because in this case we are going to use the Groovy language, a Groovy script, to compile and link edit COBOL application, and this could go as the same for PL1 or assembler for that matter. So choosing the build script is a matter of opening the same file system or accessing the same files, and here we are going to see a folder for build, and we are going to use this build.groovy. The same way I could browse a remote system. So for instance, in the ZOS USS, the Unix System Services, I could have a build script there in the Unix file system, for instance. But for this demo, I'm going to use this build.groovy script. Now I need to provide a folder that will act as a sandbox, so a place where the files, the temporary files, will be placed. So I'm going to browse this, and here I'm browsing the Unix System Services of this ZOS. So we see here inside my home CPM and Node.js. So since here we are browsing the Unix file system, we can check that starting a TSO command, then OMVS to start a Unix session. So I am IBM user, I am on my home, my directory, and we see here CPM and Node.js are the directories, the only directories we see. So now back to this browsing facility, I'm going to right click and ask to create a new folder that I will call user build. So this created this new folder that I can double check here on MVS. We see here user build, so the new directory that was just created along with CPM and Node.js. There were directories that were already there. So if I go here in our local copy of the repository in build and build.groovy, I can see the build script that is going to be used for this build process. And this build script can and will execute other build scripts. For instance, compile.groovy, and for all build scripts we can have access to copies of datasets and libraries. We can define statements. We can define the compile parameters depending on the presence of the other aspects. And we have here a build order. And so we are interested now in the COBOL compile step. And you see that we are going to iterate in between or inside all elements of build order. And the script, the other Groovy script we're going to run is COBOL compile.groovy. So we can take a look in COBOL compile.groovy and see we hear the dynamic definition of some properties, and most importantly, the compile, the presence of some compile parameters, if this is a KICS or a DB2 COBOL program. And at some point we also do copies of datasets and execute a program. So the program that will do the compilation is the same program, the same modules that we execute when we submit a JCL traditional compilation, a COBOL compilation job. And this is the way Groovy is used to define the data sets, the temporary and input and output data sets for the compile program. And closer to the end, we will have the execution of the link editor, also defining the DD statements and the language environment load libraries and DB2 load libraries. So now I have selected this newly created folder, and you see that the wizard added /work as the place to store the log files. For the destination HL key, I'm going to use dbb.user. So dbb, you know, is a high-level qualifier that is already there, and that's important because of RECF and security authorization. And now I can move forward and ask to discover dependencies. So here with this, the copybooks patient master and treatment. So these copybooks are mentioned or used by this treatment COBOL program. And because of this discovery capability of dependency-based build, these copybooks are also going to be built. So with this, I finish the wizard and the build process start. So I can see the build running, the several Groovy scripts being executed, and we will have at the end of the build log with all the details of what happened. And also please consider that using the Groovy language, I could start as part of the build process, for instance, unit tests. So I could trigger ZUnit tests. I could make connections to a quality management product such as SonarQube, or integrate in any way I need it, because I can improve the Groovy script or add new steps that need to be performed every time I build a new version of the COBOL program. The build process is now complete. I can see the log, and this log, as we know, is also recorded on the Unix file system. But we see here that the COBOL, the Enterprise COBOL compiler version 6.1 was executed. We see the invocation parameters for the COBOL, the other options that are in effect, and our source code that was used as input for this compilation. We see the copybook that was also part of the build or included in the build because of the dependencies that were found. And here our procedure division with the commands we introduced. So the display DBB demo before performing the housekeeping and after performing the cleanup. And we have here the end of the log, non-error or severe messages. And we see as well that the link editor was executed. Back to IDZ or the Open Developer, we see here the console. So from the top, we see that a shell execution of this Groovy script, leveraging the application, the binary of the Groovy on Z. And we have the high-level qualifier of the output. We have a pointer to the libraries of the COBOL compiler, version 6.1, and other libraries that were necessary for the compilation, including in this case specifically DB210 load libraries, and the return code 0 at the end of the build. And we see also that now we probably have objects in our dbb.user dataset in ZOS. We see also here the language environment libraries that were used during the build process. And if we, or to confirm that, if we go again to the dataset utilities and search for the contents inside the DBB high-level qualifier, we see now the copbook, the COBOL, and the load modules that were generated by the build process. Specifically this treatment module, we can browse it, and with a find we can see here a timestamp that this indeed was produced moments ago. So now we are able to test this program, and we can do this by using a JCL. So this is a benchmark JCL. This is a job that will execute the program treatment. So run program treatment, the program we just built, and the library that will be used, the steplib, is dbb.user.load, the library we just checked, and we saw that our module is there. So I can submit this JCL, and to do so I can right click and select submit, and here again what LPAR or what ZOS system I'm going to submit this JCL on. So in our example we just have this one, ZOS.dev, and I want to locate a job. So here I see retrieved jobs, and I see that this job completed okay, so the condition code is 0, and I'm going to see the output of this job that was executed. So here we see again the language environment, our load library, some data sets that were used, the allocation of some files, and then we start to see already some treatment records. So this is treatment record 1 and then treatment record 2, and our display DBB demo before housekeeping, then a display that is inside the housekeeping paragraph. We have a lot of records that then were read, and since I chose to see just the first 5,000 lines, I don't see the end of the sysout, but I definitely can ask to see the complete job output. And with this, after some time, I can move all the way to the end. So now I have more than 26,000 lines, and I see here the normal end of the treatment job and our display DBB demo after the cleanup. And here's some counters with the information regarding charges of medication, and that we read 2001 records. Finally, we can see in ZOS, so if I start a new TSO session and use M for more than SDSF, I can check the output of the jobs that were submitted, and this is our job that was used to test the COBOL program we changed and built. And we see here the execution, so our load library, so the same sysout we saw using the Z open development or IDZ. So we see the allocation of the files, and soon that our DBB demo display before housekeeping, the records 6, 7, 8 up to 2001, and at the end of the output we see our normal end of the program and our DBB demo display after cleanup. So this concludes our demo. I hope you have enjoyed. In this demo we used a Z-Trial environment with an x86 Windows virtual machine and a ZOS virtual LPAR emulated and running with ZDNT, Z Developer and Test, both on x86. We used DBB, so IBM dependency-based build, to build a COBOL program that we changed. And again, we could have done similar things to build PL1 or assembler programs, for instance. Thank you very much for watching. See you next time. Bye-bye. That's why searching.